Okay, very quickly, just a contribution analysis example. So let's list some givens. So we are given that the price is $4. VCRR is 0.625 or 62.5%, and the total fixed cost is equal to 225,000. So part A just asks how many units must be sold to break even. So that's using our normal break even formula, which is just price minus variable cost. So you'll notice here we don't have variable cost. So the lab manual lists two ways to solve this. I'm going to show you a third because this is so it gives you the VCRR, right? So VCRR is equal to VC divided by P. So what that says is that VC should equal VCRR times P, right? So that means that VC should equal our 0.625 times our price of $4. So our variable cost is $2.5. So with that in mind, now we can calculate what this break even is. It's going to be, our break even equals cash fixed costs divided by that. So to calculate that, it's going to equal, maybe I'll put it down here, it's going to equal our fixed costs of 225,000 divided by our price of $4 minus our variable costs of $250. So that is our break-even units. It's a big amount of units. So to go through the lab manual ways, they found they kind of used the reverse. So they used this formula, CFC divided by 1 minus VCRR, to determine the amount of revenue that they'd need, and then they divided it by the price. So their way would be 225,000 divided by 1 minus 0.625 gives you that, and then if you divide that by the price, you get the same number. So that's kind of like a backwards way of doing it that works too. And then there's another way using VCRR, but I think you guys get the idea. So B. If the company is currently selling above its break-even level of sales, what additional profit will result in sales if sales are increased by 10,000 units? So because we have our price and our variable cost, we can see that our contribution per unit is equal to 4 minus 2.5. So we're getting $1.5 on every unit. So if sales go up by 10,000, then we multiply that by 1.5, and our profit is 15,000, right? Because we're making $1.50 on every unit, and we sold 10,000 units, so we get $15,000. Suppose a company receives an order for 170,000 units. The company is currently at capacity and would have to put an extra shift to produce the order, incurring an additional $75,000 in fixed costs for the order. Variable costs would not change. The buyer has some bargaining power due to the size of the order and requests a volume discount. What dollar amount per unit must Rialto set the price above to ensure that it makes money on the order? So we want to break even on these 170,000 units. So which break even formula are we going to use? The one that gives it to us in units. Equals CFC divided by price minus variable costs, right? And this makes sense too because we were solving this question for price. We don't know what we want the price to be. What we do know is the other things. So the additional fixed costs are 75,000. Don't add the original of 225. We're assuming this is a whole separate thing, right? And then we want to know what the price, we know what the variable cost is, it's 2.5. And we know that this is going to equal our 170 units. So if we rearrange that, we get that 75,000 is equal to 170,000 P minus whatever 170,000 times 2.5 is. So 170 times 2.5, 425. 425,000. Rearranging again, we get 170 P is equal to, we'll just leave the math for later, 750 plus 425,000. And then P is equal to, I don't know why it just bolds all of a sudden. P would be equal to 750 plus 425 divided by 170, which equals I didn't want to do that. This 6.91. Oh, I put too many zeros here. Oops. So this should have one less zero. And one less zero here. And one less zero here. There we go, 2.94. So we want the price to be equal to $2.94. Or actually, we're going to round up to 95 cents, because otherwise we're going to lose money. So we need to charge a minimum of $2.95 in order to make some profit on this order. D. If the buyer was not willing to pay the above price determined in C, the only way Rialto could make money on the order would be to lower its VCRR. If the company wanted to make its normal margin on the order, 37.5%, for it to be worthwhile to put on the additional shift, what must it lower its VCRR to, and how might it do that? So, sorry, give me a second here. Okay, so we're going to use, even though they don't want to use this price, we're going to use it just to determine the break even. So for this 170,000 units, we need to multiply that by 2.95 in order to get and then we're going to multiply it by our margin that we're making of 37 times that. This is how much we would make on the units if we sold them at this price. We'd make this much. So with that in mind, we're now going to use our other break-even formula to determine what variable costs should be to change the VCRR instead. So if we want to make this amount and we're going to cover our cash fixed costs, then we're going to add those two on the top. So break even is going to equal CFC plus any profit we want to make divided by our price minus variable cost. So we know what the amount of units is. We know it's 170,000. And then we know that that is going to equal our cash fixed costs of $75,000 plus this number that we just determined here for profit, 62.5. And we're going to divide that by our price, which was $2.95 minus VC. We don't know what VC is going to be yet. So same thing here, we're going to rearrange. We're going to get, do some math here, times 2.95, 501,500 minus 170,000 VC is going to equal 7, put the right amount of zeros this time, 188,062.5. 263,062.5. Rearranging again, we get 170,000 VC is equal to 238,437.5. And then just dividing, we get VC is equal to 1.4025. So that means our variable costs should be $1.41 because we're going to round up. And in that case, RVCRR would equal VC divided by P. So it would equal 1.41 divided by our price of 2.95. And we get that 47.8%. So what does that mean? Well, currently their VCRR is a lot higher. It's 0.625. So how would they get it to this lower amount? Well, they'd have to negotiate with their supplier or something like that to get that lower number. The book here says it would not be likely to reduce its labor cost or quality, as neither option would likely be acceptable to its workers or the buyer. And that is contribution analysis. I might do one more actually. Give me a second here to find. I'm gonna do one more because there was another good one. Okay, I'm gonna do one more because this one is probably a more typical one. That was like the last question, and this is going to be the first question. So right now you have fixed costs equal to $20,000 and your variable costs equal $12 per unit, and you can buy a new machine. Right, most of these have to do with like new machines, I find. And that would increase your fixed costs to $60,000, but it would decrease your variable costs to 4 for a unit. So part A says before going to her boss with a suggestion, she needs to know if the company can sell enough to cover the costs, or if it will just result in losses. The company currently sells on average 7,000 units. So sells 7,000 units. Are we going to break even? So our old break even is equal to our fixed cost of $20,000 divided by our price, which we don't know. Oh, sorry, it says the price of the product will remain unchanged at $20 per unit. So 20 minus 12. Price is $20. Price doesn't change. This is our old break-even. Our new break-even is going to equal our new fixed costs of $60,000 divided by our price of 20 minus our new variable costs of $4. Divided by. So this is our new break-even. So we sell 7,000 units. So this is a good idea because we're definitely going to break even before we're even close to our maximum sales capacity. So that's good. So part B asks not just the amount to break even, but the amount we need to sell in order to start making more money with this new automated machinery. So that is a decision point question. And the formula for decision point is our new CFC, maybe I'll put this in brackets, our new CFC minus our old CFC divided by our new pretty sure it's contribution, but I just want to find, yeah, new contribution minus old contribution. So that is going to be the new number of units. So that is going to equal our new cash fixed cost is $60,000 minus our old of $20,000. Is that 20 or 200? Yeah, that's 20. Divided by our new contribution per unit. So contribution is the amount we make on every unit. So our new contribution, we sell the units for 20 and 4 of them go towards making them, so it's 16. And our old one is 20 minus 12, which is only 8. 5,000. So at 5,000 units, the new machine will be more profitable. So this first part was break even. The second thing we wanted to do was decision points. So the decision point, is the amount of units at which the new thing becomes more profitable than the old one. Just because you're breaking even on it doesn't mean it's more profitable. Notice it costs a lot more, right? And then that's it. That's it really for this question. Part C is just a qualitative look at it. So qualitatively, if you're replacing all the workers with machinery, might not be the best thing. That's kind of always the case. But the lab manual talks about how perhaps that would create more delivery jobs, and so you'd end up making more jobs as opposed to less. So that's kind of it for contribution analysis. Hope that helped.